Hey everybody. All right, so this is day 3 of graphing rational functions. So today we're going to focus when there's a variable in the numerator. All right, so do a quick sketch. Now a sketch, so don't find points. When I say a sketch, what I mean is I'm going to draw my axes. I'm going to include my asymptotes. Make my highlighter small. All right, so -9 is my vertical asymptote, right? 0 is my horizontal asymptote. And since it's positive on top, I know my graph is going to look something like this. That's a sketch. I would label that as -9 though. All right, so if you didn't already, try the second one. All right, so again, it's a sketch. Draw in my asymptotes. So I have +4 and +1. And I'm going to label that on my graph. So that's a 4 and that's a 1. Clearly not to scale. Okay, so then there's a negative, so that means it's going to flip. So I'm going to have this piece here and this piece here. And that's my sketch. And honestly, like, if you take nothing else away from this unit, I want you to be able to do that. All right, so how does a variable in the numerator affect a rational number? So the vertical asymptote stays the same, right? My vertical asymptote is x equals 5. What will make the denominator 5? What happens is we're going to change the horizontal asymptote, all right? So the horizontal asymptote is going to be different now. So think about it this way. If I plug in a really big number, y equals 1,000,000 over 999,995. What is that really close to? It's pretty close to 1, right? If I plug in any really, really big number, what ends up happening is if you take the x's and divide them, x divided by x is 1. That's what your asymptote. Because over time, when the numbers get really big, that 5 ends up meaning nothing. I like to call it that loose change. So we're going to take our x's and divide them. X divided by x is 1. So my horizontal asymptote is y equals 1. Now, if there's another number over here, that we'll include that as well. But basically, the only thing that matters is the x's on the top and the x's on the bottom. As the numbers get bigger, this number doesn't really have a big effect, right? There's not a big difference between 1,000,000 and 999,995. All right, so same idea as before, no big difference. What is our vertical asymptote? X equals 5. Our horizontal asymptote. The 1 and the 5 really don't do anything, so we're going to take our x's, 2x over x, and divide them. 2. So y equals 2. So those are our asymptotes. All right, so I get x equals 5. 1, 2, 3, 4, 5. And 2. Everything else is exactly the same. I'm going to find some points, see what my x's are. All right, so I'm going to put, oh no, why did it do that? Shoot. Okay, so I'm going to plug in 6. I'm going to plug in 4. Let's see. If I plug in 6, these are more annoying because you have to multiply on top. So I got 13 over 1. If I plug in 4, I get 9 over -1, which is -9. All right, let's do, I'm going to do 2x plus 1 equals x minus 5. If I set those equal, I get x equals -6. So -6, 1. And I need, like, I don't know, Let's try, I'll just do it 7. 7 gives me 15 over 2, 7.5. All right. So I got 4, -9. I got 6, 13. It's going to be like up here. I got -6, 1. And 7, 7.5. 2, 4, 6, 7.5. So my graph is going to look something like this. And something like this. Oh, another good point that you can find is if you set the numerator equal to 0, x is -1/2. So that's your 0. That's a common point to find also. All right, pause the video, find your asymptotes to start. So my vertical asymptote, x equals 1/2. So we're doing with decimals. My horizontal asymptote, now, I'm going to take my x's, 6x over 2x, and then I also have to include my -3. That doesn't go away, so -3. That becomes 3 minus 3, which is 0. So y equals 0. So we take whatever we get from the fraction and then subtract off our other constant number. All right, so let's plot those. I got 0. And I got 1 +1/2. If you want, you can scale the graph. I avoid scaling the graph, but you can if you want to. All right, I'm going to plug in 1. Let's see what happens when I plug in 1. So that's 9 over 1 minus 3, which is 6. I'm going to plug in 0. I get -3 minus 3, which is -6. I'm going to plug in 2. I'm just picking numbers, guys. And I'm going to plug in -1 also. If I plug in 2, I get 12, 13, 14, 15 over 4 minus 3. So that's 3.75 minus 3.75. And then I'm going to plug in -1. -1 gives me -3 over -3 minus 3, which is -2. All right, so 1, 6. 1, 2, 3, 4, 5, 6. 0, -6. 2.75. -1, -2. Oops. Well, that was a terrible graph, but whatever. And that's it. All right. Now, this one's a little different. So I'm going to start by rewriting it as -2x plus 1 over x plus 2, x minus 2, plus 2. All right. Horizontal asymptote. Or vertical asymptotes. X equals 2 and x equals -2. I don't put plus or minus 2 because they are equations. Horizontal asymptote. So I take the x's on the top, -2x, over x squared, and then plus 2. So this gives me -2 over x plus 2. So what happens if you plug in a really, really, really big number? You end up, this just is 0, so 0 plus 2 is 2. So y equals 2 is my horizontal asymptote. All right, so let's graph that. So I've got my 2, and my -2. All right, so now we know something weird is going to happen in the middle of these. All right, I'm going to use blue. All right, so I'm going to plug in the points on either side of my asymptotes. So I've got 3, I've got 1, and then I've got -1 and -3. Hopefully that's enough for this one. So now if I plug in 3, I get -6 plus 1, -5 over 5 plus 2. That's a 1. If I plug in 1, I get -1 over -3 plus 2. So 2 1/3. So let's see. 3, 1. And 1, 2 1/3. So I'm like there. All right, let's plug in -1 now. -1 gives me 2 plus 1 over -3 plus 2. So that's that's a 1. -1, 1. -3. What do I get when I plug in -3? Sorry, my brain stopped working. So that's 7 over 5, plus 2. So that's like 3 2/5. 3 2/5. So we got -3, 3 2/5. So there. Did I do that one wrong? When I plugged in 3? When I plug in 3, I get -5. No, I was right. Okay, so now this is what this appears to be. That. Sorry, I didn't even connect that. And then the ones we did earlier the other day, it looks like this. Now this is actually wrong. So let's think about this. If I plug in -1.5, I'm going to do this in another color. Let's do red over here. If I plug in -1.5, I'm going to just do this really quick on the calculator just to show you. -2 times -1.5 plus 1. That's 4 over 1.5 squared minus 4. -1.75 plus 2. 4 divided by 1.75 plus 2. I get -0.2857. So that makes sense, right? I'm down here. Okay. Now let's plug in 1.5. 857. If I plug in 1.5, -2 times 1.5 plus 1 gives me -2. 1.5 squared minus 4. So -2 divided by -1.75 plus 2, I end up getting 3.143. So I actually end up getting a point like right here. So this thing actually, this is an example where it crosses over the asymptote. So in the middle here, and I would say grab your calculator so you can take a look at that. The fact that it comes up and it actually goes through the horizontal asymptote and up. And that has to do with the fact that you had that -2x over x squared, that's 0. So that's a common occurrence with ones like this. So you got to really use your calculator to kind of check that we did this right. But it really comes from that idea that you have a 0 plus the 2. As x gets really close to that positive 2, it's going to infinity. When it gets close to the negative 2, it's going to negative infinity. All right, last one. Pause the video. Try it on your own. So I have 6x plus 1 over x minus 9, x plus 2, minus 3. So my vertical asymptotes are at x equals 9 and x equals negative 2. My horizontal asymptote is at negative 3. We have our 6x, highest x on top, highest x on the bottom, minus 3. So we get 0 minus 3. So my guess, when I look at this, because of what's happening here, my guess is it's going to look like that last one. Y is negative 3. X is 9. And negative 2. All right, so let's plug in some points now. Let's see what happens here. All right, so I'm going to plug in 10. I'm going to plug in 8. I'm going to plug in negative 1 and negative 3. So those are the ones I'm going to start with. And then I'm probably going to have to look at what's happening as I get even closer to the asymptotes. All right. I'm actually going to cheat, and I'm going to go on my calculator, and I'm going to put this into the function, and then I'm going to go to the table and plug in because I'm being lazy right now. I got 2.0833, negative 7.9, negative 2.5, and negative 4.417. Can I plug this in without? Yes. I don't want to. All right, 10, 2. So we're here. 8, negative 7. We're here. Negative 1, negative 2.5. Negative 3, negative 4. So this is interesting. So it looks, this side is going to be like this. Over here is like this. Whoops, I crossed it. Now, notice these 2 points. So now the question, so my guess is because I have this point down here and a point up here, is it's going to be like this. That's what it appears to be. So you can plug in like negative 1.5 and see what happens. Negative 1.5. Let's see what I get. Negative 1.5. And I get negative 1.47. So yeah, I'm getting closer to the x-axis. And then I can plug in 8.5. See what's happening there. And I get negative 12.9. So it is coming down. So that's that graph. So these are the trickiest ones. Would I give this to you without a calculator? No. It's really those others that I think you should really have a good, strong indication on how to do them without a calculator. This one is a little bit more effort when the degree on the top and the bottom is different. But that's it. All right. See you guys later. Have a good weekend.